Kat Twitter tag tak ada lah.
Tulis.
Orang-orang muda kan
Cikgu garang.
ha.
Cikgu seorang terlalu garang. Cikgu seorang tak cukup garang.
Tak start lagi dah.
Yang penting balance. Masalah. Yang penting dia got backup dia.
Faham?
Dia Nazu garang sangat. Semai tak cukup garang.
Macam terbalik. Aku tak buat satu je.
Mana dia tu? Nak tanya dia orang semua bahagia.
Dia orang betul semua kabut tak sempat jadi.
Memang agaknya memang garang tu tak sempat ke ataupun memang
Aku tak cakap kalau tak sempat kita cakap dia okey, kira-kira ni homework awak.
Dia tu memang homework. Aku dah garangkan homework. Okay, dia kita kena sempat sampai at least homework. Sebab homework tak kasi kategori.
Semua nak tahu buat lagi. Kasi macam papa cakap aku kasi masuk sekolah.
Ambil kepada apa? Ada orang yang buat auto, mesti pakai auto tu. Auto dengan hackathon. Jadi dia basic lah. Prof dengan nourishment.
Dia ada tiga dia, control,
Satu prof. Itu di proposal.
buat tiga dia satu profit. Tujuh pandai.
Sakit pun. Bapak ni tak ada
Masa tu pun training. Mana kita lagi?
aku tanya budak kelas saya tak tahu pun dia. Ini doktor ni dia yang lihat soal kan lepas tu
Tapi masa tu pagi kita dapat tersusun lah. Cuma one phase ni kena pandai lah. Kalau tak nampak macam
kalau tapi transition tu basically simple je SOST lah. Satu tu ada pakai dia. Lepas tu pengajaran dia sesuai, projek dia sesuai, sesuai. Yang tanya budak kelas saya
dia tak boleh.
aku ni saya tidak tahu.
Dia macam buat sendiri.
Aku dah aku silap lah. Tapi tak apa lah.
Aku rasa saya sebab dia orang apply je.
Campur knowledge tu bukan yang dia boleh apply. Dia hard set kan, bukan dia boleh apply.
Kan macam dia orang create a new organism ataupun
Menaruh lah. Kalau suruh create organism menaruh.
ataupun okay, macam kita panggil apa? Imaginative organism.
Makan masa pasti untuk subjek ni, untuk pelajar ni.
Yang lebih real, kita boleh buat macam ni lah. Kita bagi dia orang satu Pokemon. Itu idea awal tu. Kalau sejam lah, kita bagi group one Pokemon. Lepas tu dia orang kena assign Pokemon ni ke mana. Faham tak? Faham tak?
Ada Pokemon. Lepas tu maksudnya ada Pokemon tu.
Ada pun macam guru ke
Tak ada lah.
guru, kalau ni macam bagai, satu lah. Lepas tu kalau tu kenapa? Tapi kalau sejam boleh lah. Aku tak berseput.
Tapi jumpa pula dia orang cari BBC jadi guru buat lagi BBC British
Aku dengar
apa?
British Broadcast Channel. Tapi tu dia agak kontroversial kan. Dia orang macam journalism wise dia orang agak kontroversial. Kalau tak lain kan.
Journalism is dead lah
Western
sekarang.
Western channel ni dia orang macam mikrokompetitif.
Propaganda consumerism.
Tak, yang paling tak senang tengok kalau buat debate. Macam buat je debate tapi orang tu cakap tu tak.
Okay, good morning class.
Bonjour.
Tak semangat je dah breakfast belum?
Hello.
Belah sini semangat, belah sini.
Where?
Oui.
Okay.
Dah cikgu dah.
Dah breakfast.
Dah makan.
So today we will learn about selection and speciation. But before that, I want to show you one image.
Rest. Let's rest.
Okay, so we usually use this to make what? Strawberry smoothie.
Chocolate.
Last time we had matcha strawberry.
Jeruk strawberry.
Okay. So they
Jerky,
found out
strawberry
that
jerky.
strawberry, like back in the days, strawberries don't look like this. Did you know that? No.
Blow up.
Okay, use your imagination. What do you think the original strawberry looks like?
Kurus, tak banyak isi, not plum.
Not edible.
Not red.
Not edible. Not
Not
appetizing.
red.
Basically not appetizing. Okay. So actually this is what the word strawberry is.
Button
Asal
rasa
macam corona.
Not appetizing kan? Like corona.
rambutan.
So what do you think? How do you think? From that it becomes this.
Breeding.
Evolution.
Crossbreed. Breeding. Yes.
Genetic modification. Okay.
Selective breeding. Selective breeding.
Okay. Good. Okay, let's see some other examples. Yeah, sama cakap tadi corn. Next.
Lemis.
Memang rosak ke guys? Okay, who here likes to eat corn? Me.
I don't like to
This
eat
is
corn.
what it used to look like.
It looks that on the
Is it
toilet.
appetizing? No. And then this one?
Cabbage. Rabbit.
Who here likes to eat cabbage?
Siapa rabbit?
Okay. So did you know this?
Bapak.
All of this is one
Bapak
species,
memilih.
but they have different shapes, right? And colors.
Yes.
Okay. Next. Let's play
Peppered
a
more.
game.
Ni.
I've give in the group chat that the link to the game. Let's play some game. Open the link in your devices. Boleh tak?
Cikgu yang dekat-dekat.
Internet problem.
Okey, dah buka.
So when you open the link, this is what it should look like. Okay, so I want you to. Okay, so this is how we're gonna play. I want you to select on the front page, in the front menu, like forest.
Like forest.
And then in this game, you are a bird trying to eat.
Okay.
Okay, so try to eat as many moths as you can in the given time. But while playing, I want you to observe what type of moth is being targeted. And then after the game is over, observe what type of moth survives the game. Okay, and then I want you to repeat another time with dark forest. Okay. Give it a go.
Jarang.
Click on what you want to eat.
Spiral. Top score.
Buat rekod lah. Kita tak bodoh ke burung. Kita makan semua burung. Kalau burung je lah dia pilih-pilih.
Okay, try to eat as many moths as you can. How's it going?
Rasa aku makan banyak putih.
Okay.
Like like more color more.
Okay, looks like most of you are done with the light forest. Try with the dark forest. The dark forest setting. New game. Back to the
New game
menu.
class.
Yes. I want you to observe the different. Not just play. Make some observation, okay?
Hitam je.
Ration motivated.
Internet awak slow kot.
Cikgu cikgu jadi macam ni laptop untuk B40.
Kita nak viral. Boleh viral.
Payah pada kalau dia tak detect lah. Jom. Scammer ni link.
Make some observation while you play.
Aku sama je.
Ya.
Sama. You observe the same thing.
Logik
Tengok macam ni.
Okay, everyone finish playing? Yes. Okay.
Dah habis.
Can I have Nasha to tell us what do you observe? Which moth is being targeted and what do you see by the end of the game?
So during the light forest, as a bird, I target the dark one. It's easier for me to target the darker moth, and it's the opposite one compared to the dark forest. I couldn't see any dark moth, only the light moth, so I target the light moth.
Okay, thank you. Did everyone else have the same situation? Have the same answer? Yes. Okay, so what happened while you were playing? Because the bird can only see dark moth in the light forest, so you only target the light moth. While in the dark forest, you can only see the light moth easily, so you eat that compared to the other color, right? Okay, so what you did just now is actually what we call natural selection. Wow. Okay, so this is the definition of natural selection. Can I have Lukman to give the definition of operation based on what you played just now?
Okay, so
About natural selection.
Natural selection is a process in which individuals that have certain inherited traits tend to survive and reproduce at higher rates than other individuals because of those traits.
Okay, definisi secara operasi berdasarkan game yang awak main tadi.
Natural selection is the bird spotting light coloured moth easier in dark forest.
Okay, what happened to the generation at the end? Which one survived?
In dark forest, dark peppered moth survive at a higher population density than the light peppered moth.
Okay, thank you Lukman. So that is the definition of natural
I vote for
selection.
Obama.
Okay, so as you can see in this picture, this is what you played just now is not just a game, it happens in real life. So during revolutionary apa? Revolution, yes. So the factories release dark smokes, right? So the environment becomes very dark. That's why only the dark moths survive during that time because they can camouflage with the environment. While the light coloured moth is being targeted by predators lah.
Betul.
Okay, so next. Just now we look at natural selection that happens in animals. Now let's look at this. Just now I said strawberry used to look like this, right? Very not appetizing. fertilizing rounds, like virus looking, everything.
Skinny, not plump.
Not plump, not very juicy maybe. And here is the current strawberry that we have right now that you can see in supermarkets, right? Okay, so these are actually example of artificial selection. So what can you see in this diagram of the dogs? What do you think happened?
A lot of variety.
A lot of variety, yes.
Different breed.
Different breed, okay. And in this diagram, it shows that it comes from one
Ancestor.
one species, right?
Grey
And
wolf.
from that, they create these different variation breeds, right? So that's why you have what, bulldog, poodle,
Ada
apa lagi? Pomeranian, Chihuahua.
Dalmatian.
Okay, but imagine, do you think they have the same survival rate as the ancestors?
No.
If you put Chihuahua on the street, what will happen?
Kena langgar. Zero survival instinct.
Okay, so
All-
you
all
can
bark,
see
no
the
bite.
difference, right, between their ancestor, not just appearance-wise, but also their survival rate. You can
Betul.
imagine what will happen. Okay, next slide. Okay, so this is the definition of artificial selection. It is a process which human altering the genotype of an organism by choosing favorite characteristic for breeding. So they produce new breed lah, macam dog tadi. So kenapa kita buat different dog breeds ni?
Different kegunaan.
Kegunaan, okay?
Aesthetic wise.
Aesthetic wise. So can you see how human are so selfish?
Yes, human selfish.
Sebab tu saya tak beli anjing.
Okay.
Against breeding.
Now that I've explained about natural selection and artificial selection and gave some examples, I want you to do some comparison lah. Can I have who tell me what is the compare between natural selection and artificial, and tell me the different causes of that.
Cause dia environmental cause.
Okay.
Barang tu.
Only one population can survive, and then they have the
Bangun
they
bangun.
have better survive in environment and more stable environment.
Environment, okay. So who said the cause of natural selection is environment? What about artificial selection? Who caused
Human.
Human. That's the answer.
Made in China.
Yeah. So natural selection it's in the name lah. It's
Human
caused by
made.
nature or environmental pressure. While artificial selection is caused by human.
Woman
Okay. What about purpose? Can I have
For survival.
for survival?
Survival
Yeah.
of the fittest.
This one.
Yes.
What about artificial selection?
For use. For human use. Human needs.
Human benefits.
Okay, yes. Untuk survival and also reproduction, untuk dia survive lah. And then for artificial untuk produce organism specific traits for human importance. Next, control.
Control.
Okay. Zika, what do you think is? Can you compare between the
Natural selection.
Azika.
Environment.
Sabar. Dia tanya jawapan. Dia tanya jawapan.
Kan dah dua lagi. Yes.
What does control mean? Like,
What
who
does
is controlling?
What kind of control?
God.
Is it mine? What do you think? Okay. Can natural selection be controlled?
No, cannot.
No.
I cannot.
What about this one? Yeah. Controlled by who?
Human.
Okay.
Woman.
Okay. So natural selection. Okay. It's uncontrolled, unguided, unintentional, or artificial selection. It is highly controlled by humans. So it's intentional lah. That's the difference between these two selection. Okay, next. I will pass to Miss Imani.
Sebab environment
Thank you, Ms. Nazul. So just now, you just learned about two types of selection, right? So the first one is what?
Natural selection.
natural selection,
Natural
artificial.
selection. And the second one is
Artificial.
selection. So for today, I will cover a little bit more on what is actually natural selections and like the types of natural selection.
Okay.
So, generally, this is like the dumbbell or like the normal curve of like a normal population, without any pressure of environmental changes or like there's like no depression somehow, like there's no stresses. So this is the general one. Next, but when natural selection happens, it will turn into these three type of curves. So the first one is called stabilizing, and second one is
Directional.
Can you guess why it's called directional?
Because it choose to increase or decrease
It's
the
just
population.
one side only, right?
Yes.
Correct. So the third one is destructive, which is yeah,
Two extremes.
Extinction.
polarized into two extreme phenotypes. So we're gonna take a look on the definition of the stabilizing selection first. So stabilizing selection is where the natural selections occur. Actually, it favor the intermediate phenotype, and it act against what?
Extreme
Which is
phenotypes.
the right and also the left of the curve. So
Oh.
at the end of the selections, what will happen? Which phenotype will survive better?
The intermediate.
The intermediate phenotype. So in this topic, I want you to really remember what the selection favors and what it aids against. Okay? These two keywords you need to remember. Okay? And in this stabilizing selections, it somehow reduces the genetic variability. Can you guess why?
Yes, because a lot of member of the population has the intermediate phenotype. Hence, the ones that have extreme phenotypes is not many.
Like lost in the in the gene pool, we will lose the extreme phenotype, right? So the homozygote. Yeah, true. So next, we're gonna see one example of stabilizing selections in this. So the birth mass of human baby. So like who remember how they weigh when they are born?
Saya 2 kg.
Al.
3.2, nice.
Your
And
picture.
then 2.7. 3.8. Yeah. Okay. So if you take a look at those numbers fall in what range? Which range?
Extreme. Intermediate. Sorry.
In the median. So in our human population, birth mass of human baby are actually facing a stabilizing selection, where baby weight under 2 kilograms and weight over 4 kilograms somehow will have low chance to survive, because they will have like higher complication rate, like obesity, for example, or maybe some like diabetes and so on, like many health complications. So in our population, intermediate phenotype are being favored. So the survival rate of intermediate will be
High.
high. Right, good job. Okay, next selection is the directional selection. So as Luqman said, why it's called directional? Because it
Favors one
favors only
phenotype.
one extreme
Extreme phenotype.
like this one. So it favors one extreme phenotype. You can be like on this one or on this one, and it will act against the opposite polar of the extreme phenotype. And in this directional selection, it also will reduce genetic variability, because like at the end of the selection, or like after many years, like all of the population will only have this kind of phenotype. So we will somehow lose this phenotype, for example.
On the other extreme.
So before we change into the next slide, can you guess like what example for these directional selections? If you remember what Miss Nazul showed you before.
Peppered moth.
The peppered moth. Next slide.
I like
So
that.
yeah,
Fastest hand in
the
the world.
color of peppered moth is the famous example for directional selection. Because of what? Who can guess?
Environment.
Yeah, it's because environmental changes, because of the industrial revolution. But why we say it directional?
Because it choose one extreme over the other.
It shows only one extreme. because like in the game you play
One,
before, in the
two.
light forest, only the light moth will survive better, right? And then in the dark forest, dark moth will survive. So only one phenotype is actually have like very high chances. So in this case of peppered moth, like in real life, so before the Industrial Revolution, as Ms. Nazi said, the light-colored moth is easily to be seen. It's everywhere. You can see it everywhere. However, after the Industrial Revolution, the dark moth is seen more, and so that's why scientists say like, why this thing happening? So it's actually because of the risk of predation for the light moth is increased. Who can guess? Because of what?
Still nampak.
I guess you see.
Sulfur dioxide emission.
So the technical selection, I mean like how the selection happened is actually when the Industrial Revolution happened, there's a lot of factory, right?
Yes.
So when there's a lot of factory,
A lot of
what
soot.
comes out?
A lot of soot.
A lot of soot, a lot of
Smoke.
And those toxic soot and smoke actually kill the lichen. Who knows lichen?
Lichen.
It's a type of moss.
It's a type of moth on the tree bark. So
Lichen.
it killed that one. It killed, and the moth is light colored. So yeah, and then because of the light colored lichen is killed, so the bark is just like ordinary bark, and then it will be covered by soot later on, like it become darker, and that's why bird can see the light moth more. I mean like, so that's why they eat the light
More.
more, and the dark moth will survive better. And you know, like this number, it's not just like the selection is not just like maybe in 10 moth before the Industrial Revolution, in 10 moth you can see like one dark moth every 10 moth you see. But after the revolutions, almost 9/10, and sometimes 10/10, you can see only dark moth. The light moth population really decreased abruptly. So, yeah. So that's what revolution and industrial urbanizations do to the ecosystem. So next, the last selection is destructive selection. So in this destructive selection, as you can see, where's the selections occur? At which phenotype?
Both extreme.
Oh no.
Okay.
The selections, they favor the both extreme and
Intermediate.
it again the intermediate phenotype. So in this selection, they will create like two partitioning of the population, because like two extreme will survive better compared to the intermediate. And somehow this selection on this act against the intermediate phenotype, if it's occur in a very prolonged time and in a very high like a very highly frequency, somehow
Two species.
these two, true, correct. These two extreme phenotype end up become a new species.
Oh.
Because of another factor that we will learn next class. Because of what? Why? How can? Like just you're just killing the intermediate, but somehow like why these two species who actually the same can become
Two
different.
species.
And this selection is actually increase the genetic variability.
Oh.
You see, because like both of this will have like their own each extreme phenotype, like homozygote, right? So yeah, they will keep the gene in the pool somehow. So the example of destructive. So who like to like a bird watching here? It's a very like time taking like a long time taking hobby, right? So for destructive selection, this is like one famous example other than the Galapagos finches. Must ever heard about
Galapagos finches.
Galapagos finches. So this is another type of selection where this bird is called the seed cracker, or the scientific name is Phrenitis or Phrenitis. So this seed cracker is actually live in Cameroon in West Africa. So in a same population, they appear to have like two type of bird. I mean like they have like two different sizes of bird. Big one. So some of them have like a very big. This one is actually big. The big one, the large one.
That's big.
And then there's like a small one. So scientists like, why this happen? Because they look the same. They're actually just the same. Just the biggest difference. Just the biggest one. And when they take a look, there's actually a difference on
Diet.
what seeds they eat. So there's a difference with the diet. And somehow, those who have the intermediate, so in this research and in this study, they put like the intermediate as a large bill. So the large bill that I mentioned is actually the mega bill, like a really big, like the proportion is like a very different. If you see like this is like covered like half of the bird face, right? And this one is like a small, like a normal bird, like a tick like that.
Platypus.
Platypus. So as you can see from this graph, like which bird is actually have a lower count when they're observing?
Intermediate phenotype.
Intermediate. So as Lukman said, it actually related to the diet. So he's correct because like the small big bird can eat like soft seeds, like those like not ripe yet, like the fruit and something like that. So it will have a high chance to survive because they will eat only soft seeds. And for the large pig, they will eat the
Hard seed.
one, the big one or the hard one, right? The hard seed, and also have a high
Chance.
But for those in the middle, it's something like they didn't fit into these two food. Like these two food is like kind of like suitable for these two kind of pig, not for intermediate. So they have a difficulty to fit on either soft or
Hard.
the hard. So that's why they have low chances. And in the populations, there will like a pressure, like a selective when they lay egg, the egg will either
Be
be
less.
small or maybe like because they die in the population, so there's a depression in the middle, so they will lose in the population. So next, okay. So after we learn all three selections, I want to play. You guys got this one right?
Yes.
So yeah, we're gonna play together. So this game is actually talking about natural selection in brief. So in your worksheet, I've already put like how to play, but today we will play together. Okay? We play together one time, and then like at home, I want you to complete the worksheets. Like you need to do your own simulation and come up with the complete worksheet in the next class. Okay?
Apa? Warlords. Calls to arms.
So if you can open the game already, you can start following the instructions that I put in the worksheet. So yeah. There's like a Charles Darwin animations.
Dalam Fadil.
Yang kan duk. Oh tak apa. Mari tu pun bunyi juga. Okay, you can start the button. Yeah, you will see the Charles Darwin image over here. And then, if you want to learn more about natural selection beyond what Miss Nazu and I explained, you can turn into the natural selection button. But today we want to play this game. So at the start, you need to choose 3 phenotypes of your preference. The game is actually self-guided, so you can actually follow the instructions. But I put it in a simple words in the worksheet. Okay? So you need to choose 3, any 3. You can generate more mutation if you want. If you want like green hat, like a brown hat, a red hat. Yeah. Okay? So yeah, so in this game, there will be an environmental stresses like predation, weather. Okay, attention guys. So who can tell me what is environmental changes happen here? If you notice, fruit tree. The fruit tree. How about like what changes in the fruit tree?
Ada yang tall, ada yang tak.
There's a tall fruit tree. So what should happen to the length of the neck? The length of the neck, and then what other thing can like happen? The length of the neck, like what kind of phenotype that will be? The feet. Yeah. So in this game, basically, I want you to kind of play with the mutations. Play with the selection that you want to put. Because in the genetic mutations, you can choose which phenotype you want to preserve. So you are become the environmental changes that Miss Nazu said. Okay? And then I want you to take note on what mutation you pick and why you choose that. Yeah. Okay. So like this one, the next environmental changes is the prey. There's like a monster here.
Predator.
So what should change in your phenotype? Like which phenotype will survive better?
Longer
The
leg.
shorter one.
Longer leg.
The shorter. Okay, Hazika say shorter.
Long
Lokman
leg,
say long
long
leg.
leg.
So why not you give it a try and you jot down in the worksheet what will happen. Okay. At the end of the simulations, I want you to also write what kind of selection is actually happening. Directional, stabilizing, or actually destructive. Okay. So since I only get like less than 1 minute for today's class, so I just want to sum up now. Everyone, listen. So I just want to sum up a little bit. So how many selections happens in this world? Like two. Natural selection. So how many types of natural selection?
Three.
First one?
Stabilizing. Directional. Destructive.
Okay. So since you guys look like you can answer it, but we'll see who can survive a million years in this game, okay? Oh, okay, good. Nash has to survive. Okay. So next week, I want like at home, I want you to complete this worksheet and we will discuss it as well. Okay? Okay, thank you. Have a good day, everyone.
Senang dia dengan rasa dengan adikku. Akan sepakat. Resiko dengan predator.
Kita orang just random kat tadi. Mesti main dia semua online.
Oh.
Ready.